You know, when you pour a glass of water, do you ever stop and think about where it's been? Or where it's going next? Because every single drop is part of this massive, non-stop story that connects, well, everything. Every ocean, every cloud, every river, and yep, even us. So let's dive into that incredible journey, shall we? It's one of those simple questions, right? We've all looked outside after a storm. You see the puddles everywhere. And then, a little while later, they're just gone. So where does all that water actually end up? Well, it turns out it's not the end of the story. It's really just the beginning of an amazing adventure.
Okay, so scientists have a name for this whole adventure. They call it the hydrological cycle. And all that really means is it's the constant motion of water all around our planet, on the surface, way up in the air, and deep underground. It's this massive, powerful loop that doesn't really have a starting line or a finish line.
Now, to really get a feel for this, let's imagine we can follow a single drop of water. Better yet, imagine you are that drop. You're floating high up in the atmosphere, just hanging out with billions of other drops in a big, fluffy cloud. It's starting to get a little crowded up there, a little heavy.
And then you fall. This is what we call precipitation. It's the #1 way water gets from the sky back down to the earth. Now, we usually think of it as rain, but it could just as easily be snow or sleet or even hail. This is the cycle's grand entrance, every single time.
But here's the thing. Your trip isn't always a straight shot down to the ground. What happens if instead of landing in a puddle, you splash right onto the leaf of a huge tree? Well, your journey just took an interesting little detour. This little pit stop is called interception. Basically, the plants and trees are literally catching you midair. So from here, you might just chill on that leaf for a while. Or maybe you take the scenic route, trickling down the stem or the trunk of the tree. That's called stem flow, and it's your new path to finally reach the soil below. Okay, so you've made it. You're on the ground. But now comes a really critical moment. Your path splits, and you've got to go one of two ways. This is a major turning point in the whole cycle. So you're faced with a choice. Do you flow over the top of the ground as surface runoff? This happens a lot when the ground is already soaked. Or maybe it's a hard surface like a parking lot. Or do you soak into the earth? That's called infiltration, and it's the start of a much slower, deeper journey underground.
So before we go underground, let's follow the water drops that decided to stay on the surface. For them, the next leg of their journey is a trip right back up into the sky. So how in the world do they get all the way back up there?
While the first way is through something we've all seen, evaporation. If you ended up in a puddle or a lake, the sun's energy heats you up, giving you just enough of a boost to change from a liquid into an invisible gas. We call it water vapor, and you just float right back up into the atmosphere.
But there's another really cool way this happens, and it involves plants. See, plants are constantly pulling water up from the soil through their roots, and then they release it as water vapor straight from their leaves. This is called transpiration. You can almost think of it like the plants are breathing out water. Now, because these two things, evaporation and transpiration, are so connected and are usually happening at the same time, scientists decided to make things a little easier. They just bundled them together into one word, evapotranspiration. It's just a handy way of saying all the water that's returning to the atmosphere from both the land and from plants. So once all that water vapor gets high up into the atmosphere, it starts to cool down and it changes back into tiny liquid water droplets. That process is called condensation. These little droplets cling to tiny particles of dust or whatever's floating around up there, and they gather together to form clouds. And just like that, you're back where you started, ready to fall all over again. The whole round trip can be surprisingly fast, sometimes only about 10 days. But what about all that water that didn't stay on the surface? Remember that fork in the road? Let's go back and follow the water drop that chose to soak into the ground, the one that started a journey into the pretty mysterious world right beneath our feet.
All right, so your underground adventure begins with infiltration, just soaking into the soil. From there, you might move kind of sideways, slowly downhill through the soil in a process called through flow. Or you could go even deeper, percolating down from the soil into the layers of rock below, becoming what we call groundwater.
So where does all this groundwater end up? Well, a lot of it collects in aquifers. Just think of an aquifer as a huge, natural, underground reservoir held in porous rock. And unlike that quick 10-day trip through the atmosphere, down here, things slow, way down. Water can be stored in these aquifers for years, decades, or even thousands of years.
But get this, even being locked away deep underground for 1,000 years doesn't mean your journey is over, not by a long shot. The hydrological cycle is always moving. So, The big question is, how do you get out? Eventually, that groundwater finds its way back to the surface. It might bubble up as a natural spring, or it might slowly seep into the bottom of a river, feeding it with fresh, cool water from below. And once it's back on the surface, it's right back in the game, ready to evaporate or flow to the ocean and continue its absolutely endless journey.
So what this all really shows us is that the water cycle is just that, a true cycle. It has no real beginning and no end. Every single drop is connected in this constant globe-spanning system of movement. So that water in your glass, it could have been part of a cloud over the Amazon last year. Or it could have been deep in an aquifer under the Sahara for a few millennia. It's all the same water.
And that brings us to one last really important thought. If every single drop of water on the planet is connected in this massive system, what happens when we introduce pollution into it? A chemical that's dumped in a river in one spot doesn't just stay there. It joins this exact same endless journey. It really makes you wonder, doesn't it? Where might that pollution end up?